Welcome everybody to this virtual town hall meeting. I'm really thankful for you all to join this meeting. I guess most of us, or maybe all, wished we could be in Houston and together in person, but circumstances unfortunately are not supporting an in-person meeting, as we know, and I hope you're all safe and sound and probably working from home. So this is maybe a good time to think about data as labs are closed and you're not able to get into your machines and generate more data. We have organized this town hall and now the virtual town hall to provide you with an update of where the development of the Astromaterial data system is right now. We will provide an overview of the system for those who are new to it. And then we encourage you to ask questions. Please type them into the chat. We will gather them and then answer at the end. If there are any issues that need clarification during the presentation that we have at the beginning, please type that in and we'll try to respond directly. With that, let me briefly introduce myself. For those who don't know me, I'm Kirsten Lehnert and I'm the PI and director of the project that is going to develop and operate the Astromaterials data system. I've been running data systems for geochemistry and specifically for samples for quite a number of years. Actually, it's over 2 decades. Some of you may be familiar with EarthChem or with the system for Earth sample registration. But I'm really happy also to introduce you today to Jennifer Mays and Lucia Profeta, who are the 2 new data curators on the team for the Astromaterials data system. Okay, with that, next slide. If you're on the call, you're probably quite familiar with the Astromaterial collections at the Johnson Space Center. It's a huge collection of around 250,000 samples that are grouped in different collections, from lunar samples to Antarctic meteorites and stardust and so on. And these samples are in active use all over the world, lots of samples being distributed every year. I guess last weekend had the CAPTEM meeting to decide on the next bunch of sample allocations. So over many years, decades, data have been generated on these samples. These samples have been distributed to be analyzed in the lab, to be described, and so on. And the data that have been generated are being reused. People want access to it, but they are very dispersed across the literature. In some cases, only conference abstracts hold the data. In some cases, like for the lunar samples, compendiums have been put together that are, accessible online, but as PDFs, not in a readily usable format. A bit scary is the fact that a huge proportion of the data have never been published and are still hopefully sitting somewhere where the Astromaterial data system actually can help rescue these data, archive them, and make them accessible in the long term. Okay, next one. So this is where the Astromaterials data system comes in, and it's intended to provide an infrastructure, a whole set of systems actually to store these data, to curate them, and to provide access to these data with an intention to not only look at the past data and collect these data, compile them from these old publications and conference proceedings and so on, but also build an infrastructure that can be used for data that are being produced now and in the future, to curate them and to store, archive them, and make them accessible following modern standards of data repositories. And we will get to that. You might, some of you might have had publications recently and might have been asked by publishers to submit your data. So this is a new world for data that the Astromaterial data system is going to help manage. We have the MoonDB project that happened over the last 4 years, and this Astromaterial data system actually builds on this. The context for it is, very timely in that in the sciences in general, the notion of openness, more transparency, more reproducibility, and reuse of data has been a major focus, and NASA is no exception here. NASA has had policies coming out. Data management plans are required now for your proposals. And there is a lot of talk and planning going on what to do with data produced with NASA funding to make them more accessible and allow them to have a bigger impact on future science. And these are just 2 examples that you might want to follow up on. Okay, yeah, go ahead. So a year ago, on July 1, 2019, we started the development of the Astromaterial data system. It is currently a 5-year NASA-funded project that is executed here at the Lamont Doherty Earth Observatory in collaboration with the Carnegie Institution, Shauna Morrison, who I think is on the call. So if there are any questions to her, she will probably be available for that. And I think that we are a team that has a very long-term experience and expertise in managing geochemical and sample-based data. And we can leverage the infrastructure that we've built for EarthChem and CSAR and the developments that are ongoing for those systems will greatly expedite and help the development of the Astromaterial data system. And you have all had a chance, I guess, to look at the team here, which is finally complete as of beginning of this year. So you can go to the website for the Astromaterial data system and look up the people who you may be interacting with when you ask questions, when you submit data, and so on. So what is this project, the 5-year project, supposed to do? The first task clearly is to go into the literature and compile all the published data for the collections curated at the Johnson Space Center. There's a little graph here that clearly shows you that the biggest data set that we will compile is for meteorites. The lunar samples data have largely been compiled already through the MoonDB project. And then we have a lot of these other collections, the biggest one being cosmic dust. But we will, over time, also expand to include spectral data. And we expect that there will be publications coming out on an ongoing basis that we will include in the collection. We are then obviously very busy in developing the whole software ecosystem for the Astromaterial data system to provide online user interfaces for accessing the data, for submitting data, for managing the data sets that you may have retrieved, and so on. And then we want to support our users, in helping them to archive and share their data, put together data management plans for NASA proposals, and comply with data policies of publishers. We also, and I will at the very end come back to that, we would very much encourage people who know of data at risk to help them get these rescued, archived in the system and made accessible in the long term. Okay. So here's a brief timeline for these developments. So we are obviously in the last quarter of our first year. At the end of this year, we will have the repository online so that you can submit your data. We will have a first version, a basic version of the search capability to the system online. But you also see that over the 5 years, these systems will evolve with augmented functionality and also taking into account any feedback that we receive from you, what pertains to usability of the sites, missing functionality, and so on. We want to really build the system in a way that is most useful for all of you. There will be plotting capabilities coming on in later years and so on. So we will keep you updated always on these new steps with ongoing webinars and hopefully next time in-person meeting at the next Lunar and Planetary Science Conference. All right, next one. So just a brief status, and you will hear a little more in the 2 upcoming presentations by Jennifer and Lucy about 2 system components. But we now have a complete team that took a little more time than we had anticipated. We have the AstroMaterial AstroMat website running, and Jennifer is the one who maintains it. So if there are events, any news that you would like to share, please contact Jennifer. We have set up our entire development and operational infrastructure. Our production system now runs in the cloud at Amazon, but we have local servers for our development and staging systems and so on, containerized or in a development environment for containerizing these applications and so on. We have over the last year taken the content of the former MoonDB database and migrated that into the database that will hold the data for all AstroMaterial collections. That was necessary because changes to the database were necessary to accommodate everything that these other collections contain. We have worked very hard over the last year on building the applications for our curators to support the data compilation, the quality control, and so on. This is in testing right now, but basically complete and ready to go. Last year, I already demonstrated our bibliography module that now provides access to over 1,700 references for these collections with landing pages that provide information about the references and also showing the data sets that are in that. And as Jennifer will show in a minute, we have started to work on the search application, and she will demonstrate some of the mock-ups that we have right now. All right. I think with that, just the structure of the next 2 presentations is based on the 2 databases that we basically will operate within the AstroMaterial data system. One is the AstroMat Synthesis, where we have a real fully integrated database of data and metadata, very similar to PetDB or the EarthCam portal, if you're familiar with that. And the second one being the AstroMat Repository, which is our the metadata catalog that links to files that have been submitted by users. So Jennifer will start now giving you an overview of AstroMat, and then Lucy will talk about the repository. There is around these two storage data systems, basically, there will be a whole suite of services that will provide access to the content in both systems. There will be a dashboard for you as a user that you can log in, where you can store your submission or can have access to your submissions, or store on an interim any data sets where you can store queries or data templates for downloads and so on. There will be search and filter applications, obviously, the bibliography that I already mentioned, and access to all kinds of entities such as samples, methods for specific data sets and so on that are made available on info pages. And as I mentioned, we will link visualization and plotting tools to make filtering and selection of data easier and more meaningful. So I think with that, finally, I can hand over to Jennifer.
Okay, thanks, Kristen. My name is Jen Mays. I'm one of the data curators at Lamont, excuse me, working on AstroMat. I'm going to review the AstroMat synthesis and show you what's being developed for Astro Search version 1. Okay, next slide. Okay, so AstroMat synthesis, it's structured to integrate sample-based observations at the granularity of individual measurements and to store and link a wide range of ancillary information about the analyzed samples, the analytical process, the data source, and that's essential for the reusability of the data. So right now we have most of the lunar data in the database from MoonDB. And the next step, as Kirsten mentioned, we have more papers that will be entered to compile the non-lunar data, about 1,400 papers total, and over 1,000 of those will be for the meteorite collection. This graph is showing how the AstroMat synthesis combines the data and the metadata catalog to form AstroDB, and you can customize your download into the types of data that you want to see. And we'll show on the next slide what that looks like. So this is an example of a data table view and export. You can see the sample names, the IGSN if it has one, analysis type, analyzed material, and then the actual data from the data sets. So this is an example of what a data table search result will look like. And we're working on additional functionality where you can add and select different columns or remove them before you actually download your data set. Okay, so next I want to talk about the Astro database status. Right now, the software tools for data compilation, quality assurance, quality control, and data ingestion, are 90% completed. The search interface version 1 is currently under development. The bibliography is accessible to browse and search references. That's up right now on astromat.org. One thing that we would like is if you have data sets that you think should be included, please let us know. Okay, so I'm going to show a few mock-ups that our application developer, Juan David, has created. This is an example of what the Astro search interface in development might look like. So you'll be able to log on and create a profile for yourself. You can save queries and search results. You'll also be able to keep track of your own data submissions here. You'll have multiple options to search for data. You can search by sample number, name, by chemistry, or by reference. The next example shows you the advanced filter screen. where you can select multiple selection criteria like specific mission, specimen type, or type of material analyzed. Some of the particular criteria shown here are customized for lunar samples, but as we add data from other Astromaterials collections like meteorites and cosmic dust, we'll be adding additional search criteria suitable for their sample data. And yes, the next slide shows version 2.0, where we will have another sample search where you can include lunar and stardust and look at all of the data for those collections. So basically you're looking at samples across collections instead of just one collection at a time. Okay, the next slide is an example of a specimen profile. In this case, it's the lunar sample 12023. It will include all of the available sample data for this parent sample and includes what analytes are included in the available data sets. This is also, you'll be able to save this specimen to your profile. So if you want to easily get back to this again, you can do so. And you'll notice in the right corner, there is a box for specimen hierarchy. You can click on that. And on the next slide, this will show you how that sample fits in with all the samples related to that parent rock, for instance, for this lunar rock. So this will be in AstroSearch 2.0. That's a little bit farther down the line, but we just wanted to show you what is next in terms of the user development that we're working on. Okay, and finally, we have the search by chemistry screen. This is another way that we will allow users to search by samples by a specific analytic range. So for instance, you can search for samples that have a specific weight % of titanium dioxide, for instance. You can add multiple rows for multiple analytes and define specific minimum and maximum values. So I hope this gives you an idea of what AstroSearch features you'll be able to utilize soon. We're always open for feedback if you have any ideas on what would be most helpful for your research. So please feel free to get in contact with us if you have any ideas or feedback at all. And with that, I'm going to turn it over to Lucy, who is going to talk about the AstroMat data repository.
Thank you, Jen. Hello, everyone. My name is Lucy Profeta, and as Kirsten mentioned, I'm one of the data curators for the AstroMat repository. The AstroMat data repository is going to be a place where you can submit new and unpublished data, and you can catalog your files. You will receive a DOI. We will have versioning control. There will be an associated metadata catalog, which holds information about related publications and funding awards. You can also embargo your data, and we provide long-term archiving. The purpose of having a repository that is domain-specific is to be compliant with FAIR principles, which are findable, accessible, interoperable, and reusable. These were primarily envisioned as guidelines for data providers so that you can more easily have an open ecosystem for data, such that they will be preserved with persistent identifiers, and you will have a good documentation which will allow for reusability of the data even after the researchers themselves may not be around. This is a requirement now from publishers. You can see here that Nature has enabled FAIR data since January 2019. They are asking all researchers to publish their data in open repositories, preferably community repositories. Nature is not the only publisher who is on board with this. There are very many publishers that are adhering to the FAIR principles. And Springer has done another open data report showing that even though a good percent of users know about sharing data, we're still a long ways away of building an ecosystem where everyone understands that it is important to have your data be open, to have appropriate credit, to be able to cite it in your publications. And this is why it would be important to submit your data to a repository. So how could you submit your data now? Until the Astro repository is launched, the interim solution would be submitting either through MoonDB, moondb.org/submit data, or directly through the EarthChem portal or the EarthChem library. You can see those links on the left-hand side of the slide. Here you would be signing in with a GeoPass account, and you would be submitting your data by completing a submission form. This data is reviewed by data managers to ensure that you have enough metadata to be well documented and have a useful submission for other users. Once you submit your data, it goes into the EarthChem library backend. And after review of the data by the data curators, it would be published and you would receive a DOI. As you can see, there are multiple metadata fields, including related publications, keywords, abstracts, and of course, proper citations. The data can be embargoed for up to 2 years. So if you are submitting your data while your publication is in review, you can keep your data private. And you can also have links to samples if your samples are registered with IGSNs. Currently, there are about 30 submissions from researchers already in the EarthChem library that pertain to lunar data and meteorites. All of these data sets will be available in the Astro repository once it is launched. Just to sum up what the Astro repository can do for you, you will be able to publish and archive your data. So you would be able to comply with the data management plans of NASA or NSF. You would receive a DOI, a digital object identifier, so that you can properly cite your data and receive credit. Data and metadata will be quality controlled and reviewed so that you will be ensuring users have very good data to work with in their own studies. And you will be able to embargo your data for up to 2 years, as I previously said. We should know that you can also choose your license so that credit and reuse are done in a responsible manner. And with this, I think I'm going to hand it back to Kristen, who will talk to us about data rescue.
All right, I hope I'm back and can be heard by everybody because I had muted myself in between. So yeah, I wanted to come back to the data rescue. We had in our data facility, AIDA, some years ago, about 5-6 years ago, an initiative that provided actually support for researchers through what we called mini awards. We helped researchers compile, organize, format any data that they had sitting around from old times. This was the mini award that went to John Delano, Eric Howry, Alberto Sall, and Chuck Shearer for compiling major element analysis, microprobe analysis, and that was a really good effort, a very successful activity. And we have since encouraged people, if they have data that is from the early days of lunar research or meteorite research, when publications were simply not able to accommodate large endless data tables with numbers. To make sure they send this data in, deposited in the either EarthChem library or in the hopefully this summer directly into the Astromaterial data repository. We are here to help you get these efforts underway, get them completed, or if you know about data sets where nobody is actually able anymore to get these submitted and so on, we are happy to help take them on here into the facility and make sure they get digitized and included in these collections. So we hope you will contact us if you know of anything. This is particularly meant for senior researchers who may still have lots of printouts from mass specs and microprobes of long ago. We are definitely interested in including these data. So if there is interest, we will run a specific webinar for how to rescue the data, how to format things, and so on. So that's why please get in touch with us. Also talk to your colleagues, to your supervisors, and so on, if you know there is a lot of data still sitting somewhere unpublished. Okay, with that, next one. So what can you look forward to? Obviously, I showed that timeline earlier. So that means that we have a number of system releases coming up by the end of the first year. We will have a complete compilation of all the lunar meteorite data this summer. We will start then with the compilation of meteorite data in this summer. And depending on how worldwide travel will evolve over time, we're likely to run another sort of town hall or lunch workshop at the Meteorological Society meeting in August. As we showed, the AstroSearch and Dashboard version 1 is under development, and we are looking forward to release the prototype in July 2020 for you to test and provide us with feedback on that. We plan to release the AstroMat repository by July. Please use the MoonDB website to submit your data, or directly the EarthChem library. Whatever gets submitted that pertains to lunar samples or meteorite or any other of the collections will go to the Astromaterial data system. It will definitely be integrated into that system, even though it's submitted through a different website. And then we plan in July or August to organize another webinar and really introduce live the new releases. All right, and I think with that, we're basically at the end, just with, you know, throughout this publication, we have multiple times said, please participate in this effort. This is intended to be a community data system. So we're looking forward to receiving your data, curating them, publishing them, and let us know about anything that's out there already that should be linked or integrated. This also pertains to other functionality. You know, we know of the open microscope linking up with images of thin sections of the samples and so on. We're very grateful to know what's out there and what we can connect with. In the bibliography, you have a button to submit any references, any publications that we may have missed in our current bibliography. Encourage your colleagues, as I said, and thank you all. Take care.